Today we're going to do a read aloud on bridge bases. There are more than 500,000 bridges in the United States, and you rely on them every day to cross obstacles like streams, valleys, and railroad tracks. But do you know how they work? Or why some bridges are curved while others are straight? Engineers must consider many things, like the distance to be spanned and the types of material available, before determining the size, shape, and the overall look of a bridge. Since ancient time, engineers have designed three major types of bridges to withstand all forces of nature. The beam bridge consists of horizontal beams that support at each end by piers. The weight of the beam pushes straight down on the piers. The farther apart its piers, the weaker the beam becomes. This is why the beam bridge rarely spans more than 250 feet. If you look to your right, you will see a picture or illustration of a beam bridge. The continuous span gave beam bridge the ability to span great distances. A single beam bridge rarely spans more than 250 feet. But as in the Chesapeake Bay Bridge Tunnel, several beam bridges can be linked together and creating what is called a continuous span. Take a look at this picture, and you will be able to see how the forces are at work. Beam bridge, forces. When something pushes down on the beam bends. Its top edge is pushed together and its bottom edge is pulled apart. The movable bridge, like George P. Coleman Bridge, has a deck that moves. A swing bridge has a deck that rotates around a center point. A drawbridge has a deck that can be raised and lowered. A bascule bridge deck is raised with counterweight like a drawbridge, and the deck of a lift bridge is raised vertically like a massive elevator. The next bridge is the truss bridge. It consists of an assembly of triangles. Truss bridges are commonly made from a series of straight steel bars. The Firth or Forth Bridge in Scotland is a cantilever bridge, a complex version of the truss bridge. Rigid arms extend from both sides of two piers. Diagonal steel tubes projecting from the top and bottom of each pier hold the arms in place. The arms that project toward the middle are only supported on one side, like really strong diving boards. These diving boards, called cantilever arms, support a third central span. Truss bridge forces. Every bar in the cantilever bridge experiences either a pushing or pulling force. The bars rarely bend. This is why cantilever bridges can span farther than beam bridges. The arch bridge has a great natural strength. 1,000 years ago, Romans built arches out of stone. Today, most arch bridges are made of steel or concrete, and they can span up to 800 feet. How are arch bridges built? Building an arch bridge isn't easy since the structure is completely unstable until the two spans meet in the middle. For years, engineers used a technique called centering, in which a wooden form supported both spans until they were locked together at the top. A new method supports the span using cable anchored to the ground on either side of the bridge. This is how the New River George Bridge in West Virginia was built. arch bridge forces. The arch is squeezed together, and this squeezing force is carried outward along the curve to support at each end. The supports called abutment push back on the arch and prevent the ends of the arch from spreading apart. The suspension bridge can span 2,000 to 7,000 feet, way farther than any other type of bridge. Most suspension bridges have a truss system beneath the roadway to resist bending and twisting. As you can look to the left, there is a picture of a suspension bridge, the Golden Gate Bridge. Cable stay bridge. The cable stay bridge, like the suspension bridge, supports the roadway with massive steel cables, but in a different way. The cables run directly from the roadway to a tower, forming a unique A shape. Cable stay bridges like the Sunshine Skyway in Florida require less cables and can be built much faster than suspension bridge. Cable stay bridges are becoming the most popular bridges for medium length spans, between 500 and 3,000 feet. Suspension bridge forces. In all suspension bridges, the roadway hangs from the massive steel cables, which are draped over two towers and secured into solid concrete blocks called anchorage on both ends of the bridge. The cars push down on the roadway, but because the roadway is suspended, the cables transfer the load into compressions into the two towers. The two towers support most of the bridge's weight. Now that we have explored all of these different types of bridges, the beam bridge, the truss bridge, the cantilever, the arch, the suspension, and the cable stay, which type is your favorite bridge? Take a moment and think.